Hello ladies and gentlemen, I'm Dr. Claudia Albers, Planet X researcher and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled, Where Do Brown Dwarf Stars Clustering Around the Sun Come From? Now there is overwhelming evidence that large numbers of brown dwarf stars, or as I more recently like to refer to them as stellar remnants or stellar cores, all clustering in the sun's corona. These objects are obviously old stars made up of the core of what was once a main sequence star and an ionizing envelope made of plasma. And this ionizing envelope is made out of plasma in the solid and liquid phase. And so these stars then transform this plasma into gaseous plasma, which they exchange with the sun through a magnetic connection. And I have written extensively about this mechanism, but it is similar to what white dwarfs do. White dwarfs also draw plasma from main sequence stars. So I have written extensively and shown that these objects are really white dwarf stars that have gotten to the point where they cannot emit much visible light. And so these are old stars that have gone through the red giant and the white dwarf phases and have released most of the material in their outer layers. And eventually, through this process, they become what's called a brown dwarf star. Now, this is a recent image from, it's a stereo A core 2 image. And what we see here is a very large object. And this object is basically a very large stellar remnant or a very large brown dwarf star. You can see it's clearly circular in shape and therefore solid. It's a solid object and it's revealed by the CME that is coming from the sun. And this is not the only object of interest here. There are several other objects and there are smaller stellar remnants visible here. And these are the stellar remnants that I'd like to, there are a lot more in this image, but what we see is these dark circular shapes surrounded by a ring type structure that is emitting some light. And these are therefore stellar remnants or smaller brown dwarf stars. They come in several sizes. They range from the size of the Earth to sizes that are much larger than the sun. The sun size here is indicated by the white circle, whilst this object is much larger. It's at least twice the size of that circle, so twice the size of the sun. Now, this object looks quite dark, even with the CME going over it. So it's possibly has not been in the sun's corona for long. They do take a while to start emitting light, and I call that rejuvenation. Now, so we get several shapes. That large one appears to just basically be the core of what was once a main sequence star. We do get the smaller ones that we see here. This object was photographed close to the sun. It's quite clear that it has a toroidal or donut-shaped envelope around it. And white dwarfs are supposed to have this kind of envelope, and it has a hole in it, and through that hole we can see the core of the object. And this is the kind of structure that white dwarfs are supposed to have, except that they are much brighter. These objects are called brown dwarf stars because when they come into the solar system, they do not emit much visible light. But this one obviously has started being able to emit light from its ionizing envelope. But this ionizing envelope is still in the toroidal shape, eventually I think it will go into the shape that main sequence stars have, which is a spherical toroidal shape where they look more spherical. But I think they retain this sort of symmetry, which is the symmetry of the magnetic field that these objects have. The toroidal shape does not seem to be associated with fast rotation, although the objects do rotate fast and have strong magnetic fields, which they developed in the white dwarf phase. But the toroidal shape, and I have written about this before, has more to do with the symmetry of the magnetic field, which is basically like the magnetic field of a ball magnet. So the magnetic field lines come out of the North Pole and go in through the South Pole. But we can see that there are these objects with this toroidal shape. Now the Sun itself has started looking more and more toroidal because it's developed these huge permanent coronal holes at the North and South poles, and you can see in this X-ray image how much like a toroid the Sun has started looking like. And this is the basic toroidal shape that we see these objects have. And most stars, though, are spherical toroidal in shape. That is, they look like spheres. But the Sun still looks like a sphere, but it's starting to develop this a bit of the toroidal shape. And this could be because it's reversing what we see these brown dwarfs doing. As they rejuvenate, they become more and more spherical, whilst the Sun is going from spherical back towards the toroidal shape as it loses energy. So this is the blue stellar core. It was about 1/3 the size of the Sun, and you can see it has, or it had when it was first photographed, these blue stripes. So it looked like it had blue stripes, and it was losing material. Later on, this was a photograph taken in May, this was a photograph taken in August, and the stripes became just patches of material on the surface of this object. It turned out to be obviously solid because we can see grooves in the surface, and it's a solid object. And this is when I realized that these are cores of what was once main sequence stars. And these are basically old stars, and we know they are stars because they are at home in the Sun's corona. And planets would not be at home in the Sun's corona. They would be destroyed in such an environment. But these objects are at home in that sort of environment, and they pull plasma from the Sun. They ionize their own materials. You can see this object has this dirty yellow plasma here and this magenta plasma here. We do know that these objects often emit magenta light, and it seems that this object is not only pulling plasma from the Sun, and the Sun produces white plasma. We can see this plasma is almost white, but the plasma associated on the surface of the object is magenta colored. So it's obviously emitting magenta light from the plasma that it obtains from the Sun. It's very strange, but it may explain why we have magenta colored sources of light illuminating our atmosphere. And that is because these objects absorb plasma from the Sun, and then they gain their own ionizing envelope, but they do not emit white light like the Sun, but magenta light, which is a mixture of red and blue. So the green would be missing. However, this yellow that we see here, yellow is a mixture of red and green, so the green frequency is mixed in there. And I'm not sure whether this object is getting this plasma from another star, or if it's ionizing it itself from its material, that it's ionizing material, its plasma from its envelope, that it still retains. It's possibly exchanging it with the Sun. Now, but we do know that we have light sources in our skies that are illuminating our atmosphere and producing this sort of effect. This magenta color clouds, red, and we actually see it looks like there's an object there. It's round. That may be the source of the light. It cannot be our sun. That is not our sun in its normal state. It could possibly be our sun that has changed in some way, has been changed by these objects, but sometimes it looks like there's multiple light sources producing this sort of effect. I've recently looked at the sky at sunset, and all along the horizon on every side I could see strange magenta colors. So I think there are possibly more than one light source, rejuvenated brown dwarf stars that have gained enough plasma and energy from the sun to be able to operate once again as main sequence stars, except they are not emitting white light like our sun is supposed to be, but they seem to be emitting these strange colors like this magenta color. And here on the side we see these yellow clouds, and these would obviously be because there is a light source in the sky that is emitting this dirty yellow color, like we see this color being emitted from the plasma associated with this blue stellar core. So it's very strange that we are having these light sources. I have written extensively how these objects come into the solar system. They only emit infrared light in the beginning. They seem to rejuvenate by being in the sun's corona, and they are eventually able to emit their own light and operate much like main sequence stars. Now, a lot of research has been done in brown dwarfs nowadays. Brown dwarfs, we are told that the standard theory for brown dwarfs is that they are objects that are somewhere between a star and a gas giant planet. And but yet these brown dwarfs are, and the research show, are very similar to the brown dwarf stars or stellar remnants that we have in the inner solar system. And the reason for that, and we can see here, this is research that has been done on brown dwarfs, and it shows one such brown dwarf, HH1165, has a huge jet plasma ejection. And these are another two brown dwarfs. This is the Lumen AB system. And again, we see that it's enveloped in a cloud of gas. And the cloud of gas would come, and we see a cloud of gas here associated with this brown dwarf as well. It's usually associated with a star going through the red giant and the white dwarf phase. They do release their outer layers of material, which becomes a diffuse cloud around the object. So whenever I see clouds of gas around a light source, I always think that it is a brown dwarf star in the terms of a stellar core, an old star, not actually a brown dwarf as the standard theory now says brown dwarfs are, which are objects that formed in such a way that they are somewhere between a star and a gas giant planet. So these so-called standard brown dwarfs behave much like the stellar cores that we have in the inner solar system, which are old stars. And we can see these two objects move together as one. In other words, they cluster, just like we see the stellar cores in the inner solar system do. So the research shows that these objects are not only faint and emit mainly infrared light, just like the stellar cores in the solar system. They have jet plasma ejections like this one. They cluster together just like the stellar cores in the sun's corona seem to be doing in the solar system. And these two objects have, as you can see, they produce the same the same illumination, they have the same brightness. It's very unlikely that a binary system is made up of two stars with exactly the same absolute brightness. This is astounding, and this would suggest to me that these objects are clustering together. That's why they're moving together, and they are absorbing energy one from the other until they reach equilibrium, which produces two objects with exactly the same brightness. So these objects that are classified as brown dwarfs behave much the same as the brown dwarf stars or the stellar cores in the inner solar system, and that to me suggests that what the standard model of brown dwarfs or we are told are actually old stars. They are not brown dwarfs or objects that are somewhere between a star and a gas giant planet, but they are actually old stars. And these old stars are what we observe in the inner solar system. These objects that are being studied are usually many light years away. So being able to study them at a close quarters in the inner solar system, clustering in the sun's corona, should give us a much better idea of what these objects really are. And it's possible that this whole idea of these objects being brown dwarfs in terms of not actually being old stars has been done in order to hide the fact that these objects are in the inner solar system, and to obfuscate the understanding of what these objects really are. They are old stars, stellar cores. And when I was a student, the term brown dwarf always referred to an old star that had gone through the white dwarf phase and had now cooled down to the point that it only emitted infrared light. And I have gone over the research done at around the time that Dr. Harrington was doing his research in the early 1982s. And brown dwarfs were referred to as dead stars, old stars, and stars that did not emit visible light. So it's exactly the same terms that I have already been thinking of whenever I call the objects close to the sun brown dwarf stars. And as you can see here, these are the brown dwarf stars in the solar system. They have jet ejections, they have plasma loop ejections. The plasma loop ejection shows us that they have strong magnetic fields, and they have these plasma ejections just like the standard brown dwarfs many light years away. And they also produce these kinds of explosions. This cannot be a planet, this cannot be the sun, so this has to be from these extra stars in the solar system. And because they are white dwarfs, and white dwarfs are known to have nova outbursts, and a nova outburst is when a white dwarf becomes suddenly very bright for a while and then goes back to its normal brightness. And it seems that the brown dwarf stars in the solar system are able to do the same thing. They suddenly become very bright and then they go back to its normal brightness. So it looks like they suddenly grew by quite an amount, and then they go back to their normal size. Now, research done by Korliska Music from the University of Lisbon and Alex Scholz from the University of St. Andrews. And this was published by the Royal Astronomical Society, reported in an article from July 5th, 2017. And this article was in the Science Daily, that there may be more than 100 billion brown dwarfs in the galaxy. And by now, I think you understand that brown dwarfs mean objects like the ones we have in the solar system, clustering in the sun's corona. And their research shows that they may be 100 billion. They actually suggest they may be a lot more, because these objects are so faint. And the article actually ends by saying that these objects are ubiquitous. In other words, they are extremely prevalent and present everywhere in the galaxy. So if there are so many of them in the galaxy, it's not surprising. And the fact that they do cluster, we know that by observing them in the sun's corona. And they do this because they not only absorb energy from main sequence stars, they do it from each other as well. So it's not surprising that if one came in towards the sun, many more, perhaps thousands, would follow. And this seems to be what has happened in our solar system. But why would we find so many close to the sun at this time? Well, it is possible that they encountered the brown dwarf star Nemesis. I have written about it recently, which is the sun's binary twin, which seems to be coming in from Orion. And it was discovered in 1983. There's lots of evidence that's when it was discovered. Or it could be the small faint red star, which many people call Nibiru or Planet X, which seems to have been also discovered by Dr. Harrington in between 1991 and 1993. He seems to have been killed because of his discovery. It could be that either of these objects, or perhaps both, have attracted these objects, because these objects came from further outside the solar system and have perhaps attracted some of these brown dwarf stars and showed them the way to the sun. So that there may be a connection between Nemesis, Planet X, and these thousands of stellar cores that now seem around our sun, and have all at the same time found their way to a position which is quite close to the sun. So there may be, I think, a connection between all this. Now, one thing is for sure, there are extremely large changes happening in the solar system right now. Our sun is becoming extremely active as a result of its interaction with these objects, as they seem to be provoking the sun to have ever larger solar flares and CMEs, even as it weakens. It is therefore possible that eventually a kill shot will issue from the sun that will end our technological age and possibly bring our civilization to its knees. And this may happen before the sun becomes too weak to emit any visible light at all. In conclusion, the sun will not be able to indefinitely emit visible light and heat in the face of the constant withdrawal the stellar cores in the sun's corona are making. Eventually the sun will go dark, but it may just get a lot hotter and dangerous before then. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.